Hi, thank you for joining us for this session on securing your Tekton pipeline. My name is Vincent Demeester. I'm a software engineer at Red Hat. I'm the architect of OpenShift Pipeline, which is the distribution of Tekton pipeline that we ship as part of OpenShift. And I am one of the lead of the Tekton community upstream. The agenda for this talk is we'll describe a little bit what Tekton is in a nutshell and go through some concept and resources. And then Ivan will go and go over what is Open Policy Agent, OPA, and how it fits with Tekton. And finally, we'll jump into a demo. So what is Tekton in a nutshell? Tekton is an open source project that aims to provide a set of shared and standard components for building Kubernetes style CRD system. We'll go a bit more how it does this. It's governed by the Continuous Delivery Foundation, and contributions are coming from a lot of companies, Google, Red Hat, CloudBees, IBM, Pivotal, and many more like Apple, etc. It's a very active community right now. So in a nutshell, Tekton allows you to define standard Kubernetes style pipelines. What this means is we are using custom resources definitions, CRD, that is a standard construct in Kubernetes for the user to describe his pipeline. This means you would describe your pipeline with the same language you describe your services or your deployments or even your pod. And this also means you can use all the tools you are used to while interacting with Kubernetes, but with Tekton. Everything runs into containers. Your pipeline, your task, your steps, all those concepts will run into containers, and even the control plane of Tekton will run into containers. You can build images using Kubernetes tools. Of course, building an image is just one thing Tekton can do, and to build those images you can use anything that would run into a container, so source image, buildah, candy code, jib, co. You can even use Docker in Docker if you have the right permission on your cluster to do so. Usually in your pipeline you also want to deploy things, and you can deploy on multiple platforms. Of course you can deploy on Kubernetes, but it's not, you don't need to deploy on the Kubernetes you're in. And you can deploy on virtually anything as long as you have the tools inside your image. One example of this is if you're using the Orca command that is coming from MaxStadium, I think, you can provision MaxStadium OS6 images or machines, and you can run new tests against it and then destroy them after. And also Tekton ships or provides some powerful user interface. Upstream there's two user interface. One is the CLI called TKN, which allows you to interact with your pipeline and your tasks, your logs, start new pipeline, etc. Using your command line. And there's the same on your web browser, which is the Tekton dashboard. There is also additional components that are developed as part of Tekton, like triggers, results, etc. But we won't dig into this because this is out of the scope of this talk. So a few concepts. Usually we do split the concept into two categories. On the left, the definition types. On the right, the runtime or execution types. So on the left, you have initially the step. What is a step? It's just a command that will run into a container with a set of environment variables, volumes. Anything you can define on a container spec in Kubernetes is something you can define in a step. In addition, you can define scripts. Like instead of specifying a command, you will define a script that will be executed as part of your task or your step inside your task. After the step, there is the task. A task is just a list of steps that will run sequentially right now in the same pod. So you can use volumes between steps to exchange to exchange data, but because each step is its own container with its own image, etc. And finally, you have the pipeline, which is a graph of tasks with some inputs and outputs. Inputs and outputs could be pipeline resources, but they are deprecated, or could be workspace, parameters, secrets, etc. And this graph of tasks is obviously going to be executed in a certain order, and as it's a graph, some tasks can run into parallel, some tasks could wait for others, etc. We'll dig a little bit more into examples. On the right side, there is the execution part. So when you define a task or a pipeline, you define what it should do, but when you apply them to your cluster, nothing is going to happen. You need to actually start it by creating a task run for a task or a pipeline run for a pipeline. And what you do is you're referencing a pipeline for a pipeline run, for example, and you bind things to it. You actually pass the correct parameters with the correct values. You pass it the workspace you want to work on, etc. There is a concept that is struck out in the slides, which is the pipeline resources. It's struck out because as of today, the API is v1 beta 1, and pipeline resources are still alpha and are deprecated. So when we reach GA, v1 API, we will remove this concept. So yeah. So in a schema, this is how it looks. You have your pipeline, which is composed here of 4 tasks. The task 1 has 3 steps. The 2 tasks are depending on this task 1 and have 1 step, and there's a final task that just depends on the one on the top that has 2 steps. The I and the O in circle are the inputs and outputs. They could be here in this example they are pipeline resources, but they could be parameters, workspace, etc. And you have the pipeline run on below, which is gonna reference the pipeline, pass it some pipeline resources, and this will result in a bunch of task run, at least one for each task defined in the pipeline. There could be more than one because there's a retry mechanism that can be defined and that can allow the user to say, I want to retry this task twice or thrice or many more time until it succeeds. But yeah. So let's look a little bit of how it looks in a YAML Kubernetes. So as any Kubernetes object, there's the API version and the kind. The API version for pipeline is tekton.dev/the version. Right now we are at the version v1 beta 1. And the kind for a task is going to be task. Then you have the metadata with the name, the labels you can put on this, etc., annotation. And the spec, which is the core of the task. Here we show just the parameters, so you can define a set of parameters that will that the pipeline or the task run will need to specify when executing this task. So this can be things like the folder you want to be in, the tag, your image, etc. It can be anything. You can pass either strings or array. Then there's the steps. So here each step can be named. You can also have unnamed steps. Here we have one step which is build, and it's going to use the image Golang with the tag 114, and the command will be go build /./, which is going to build whatever is in the current folder and the rest of the hierarchy. You can have more than one step. In addition, you could specify workspace, etc. One thing to note, here we are using command. Instead we could use script, and under script you would give it a script as a text, and the script is not limited to any language. So by default, if you don't specify any shebang, so hashtag and exclamation point, it's going to use bash, but you could write your script in Python, in Ruby, anything that can be scripted. As long as the image you're using has the binary, it's going to work. And now we can jump on the pipeline definition of Tekton Pipeline. So similarly, API version kind. Here the kind is pipeline. The name is Golang build. And the spec is going to have parameters, workspace, anything that you would have also on task. Here I kind of ran out of space, so I didn't put them. And you're going to have the task. So here we have two tasks. The task named checkout, which will check out the code. So for example, it's going to take the git shine, the URL to clone. And then we have the my build task, which is going to refer a task named build, which might be similar to what we defined before. And we give it some parameters, etc. And you can note the run after. So this is how you declare dependency between tasks. Here we are asking pipeline to run my build after we did the checkout, obviously to get the source code. And yeah, that's a quick introduction to Tekton Pipeline. Now I'll give the hand to Ivan to talk about OPA.
Thanks, Vincent. Hi, I'm Ivan Font. I'm a software engineer at Red Hat, and I'm focused on securing software supply chains as part of the security team in the CTO office. So what is the Open Policy Agent? OPA is an open source CNCF graduated project and is a general purpose policy engine. OPA enables you to decouple the policy decision-making from policy enforcement. So your application can offload policy decisions to OPA using a query. To understand this a little further, let's take a look at this diagram. Let's say you have an application service running somewhere. This can be any application service running in any system, whether that's inside of a cluster such as Kubernetes or outside. At the top, we have a request that comes into the service. From there, the service needs to evaluate some policy that it needs to enforce. The service then queries OPA by passing it JSON as input as shown on the left. OPA then uses the policy and the data it has access to evaluate the query and returns the result to the service in JSON format as shown on the right. The service then interprets the decision result in order to enforce the policy. Here are some of OPA's features. At the core of OPA is a declarative policy language called Rego. With Rego, you can write extensive policies that include arrays, objects, or collection of values. OPA is written in Go and is designed to be easy to integrate with any layer of your software stack. That's because you can deploy OPA as a host-level daemon, a sidecar container, embed it as a library within your own Go application, or compile your Rego policies into WebAssembly modules. OPA has management APIs that allow you to fetch policy and data from an external service, upload its decision results to an external service, or upload its status to an external service for offline processing. OPA also has extensive tooling so that you can build, test, and debug your policies. It has a unit test framework for testing policies. It integrates with multiple IDEs such as IntelliJ and VS Code, and has a really cool interactive playground to experiment and share your Rego policies. Now let's move on to Gatekeeper. So what is Gatekeeper? The most popular use case is using OPA within Kubernetes as a Kubernetes admission controller. The Kubernetes native way of integrating OPA with Kubernetes is using Gatekeeper. Gatekeeper provides an extensible admission controller for defining and enforcing policy over Kubernetes. It embeds OPA as a library and uses OPA to evaluate policy decisions. Gatekeeper also defines custom resource definitions for admins to define their policies once and reuse them across different contexts. This diagram demonstrates how an API request flows through Kubernetes and the layer at which Gatekeeper operates within that flow. Kubernetes provides a plugin model to register webhook admission controllers for different use cases. You can see here that Gatekeeper registers itself as a mutating and validating admission controller that allows you to evaluate and enforce your policies using OPA. Here are some of the core features of Gatekeeper. Gatekeeper enables us to write policies as declarative configuration using Rego and the constraint framework. The constraint framework is a set of custom resource definitions that encourages reuse by allowing templates to be developed, tested, and shared due to their parameterized nature. Gatekeeper has an audit feature that allows you to periodically evaluate the compliance of your policies. And it also supports dry run so that you can easily roll out new policies without breaking existing workloads. Now let's talk about Conftest. Conftest is a utility that embeds OPA as a library and helps you write tests for structured configuration data in many formats such as YAML, JSON, XML, and many others. You can use it as a command line utility or as a container image. There's also a Conftest Tekton task hosted in the Tekton catalog that makes it easy to integrate into your Tekton pipeline. We'll be making use of Conftest later in the demo, as you'll see. Now that we've gained some understanding about what OPA is and how it integrates with Kubernetes using Gatekeeper, we can shift towards how to integrate OPA with Tekton. One of the best use cases for Tekton and OPA is to leverage OPA to secure your Tekton pipelines to create a DevSecOps process. But how do we do that? This is a diagram to visualize the flow of execution for a Tekton pipeline. Gatekeeper can be inserted into the flow in several ways. Here we see OPA being used with Gatekeeper as a validating admission webhook to evaluate policies to determine whether it should allow or deny the deployment of your application. This is near the end of your pipeline and acts as a last resort safety net before persisting to etcd. Gatekeeper can also be inserted earlier in the pipeline to effectively shift left your DevSecOps process. In order to insert OPA earlier in the pipeline, we can leverage the server dry run feature of Kubernetes to allow the Gatekeeper admission controller to pass or fail the pipeline before proceeding with the rest of the pipeline tasks. Lastly, in this diagram, we show how we can also leverage Conftest to evaluate our policies early in the pipeline, while still using Gatekeeper as that last resort before allowing deployment into the cluster. When working with any Kubernetes APIs, such as deployments, services, CRDs, etc., you can use either Gatekeeper or Conftest to evaluate policies in your Tekton pipeline. But Conftest is vital to evaluate policies if you have some form of structured data that is not in the form of a Kubernetes API, such as results from some process in your pipeline. Now let's demonstrate how to integrate OPA into your Tekton pipeline using all three approaches we just visualized. All right, I have a Kubernetes cluster running here with Tekton and Gatekeeper installed. I'm currently at the root of our OPA example app repository that we're using to demo, and here's the contents of the repo. This application is a simple Hello World web application containing the Go source code and Docker file for building its image. All right, let's say you're a developer and the application is already deployed and running. The application is built and deployed via Tekton pipelines. As a developer, let's say you come in on a workday morning and you have a task to do to make some changes to the application. Now you want to test the application, so you build a container image to test it before deploying to production. You then push the container image to a container registry repository that you have access to. Now, in order to deploy your test image and test it, we'll need to make some changes to the deployment manifest for the application. A quick sed command will help replace the container image in our deployment manifest. Then we verify the changes we want to commit. Then we commit and push the changes. Of course, the use of a test registry such as this example is exactly the kind of thing you want to prevent. So while the commit is flowing through the Tekton pipeline, we can look at the Gatekeeper constraint template and constraint resources that are configured to prevent unauthorized registries from being used to deploy images. Here we can see the constraint template defines a new CRD called Kubernetes Trusted Registries. And it takes an array of trusted registries. It then defines a Rego policy template that, given the set of trusted registries and container spec as input parameters, will make sure that the container image specified in the container spec is using a registry that's in the list of trusted registries. All right, now let's take a look at the custom resource instance of the Kubernetes Trusted Registry CRD. And here it lists the Kubernetes API resources. We have pods and deployments because they embed the container spec as a template. The pods and deployments that exist in the OPA example app namespace will be passed to Gatekeeper along with the trusted registry quay.io. Lastly, the enforcement action for this policy is set to deny, so that we actively enforce this policy. Now let's observe how the pipeline run is doing using the Tekton CLI tool TKN. All right, let's scroll up a bit. And we can see that we successfully fetched the repository, built and pushed the image, but when we go to apply the manifest, in the last step there, it failed. Why did it fail? Well, the error reads, admission webhook validation.gatekeeper.sh denied the request. Denied by trusted registries, which is the name of our custom resource shown previously. Container OPA example app has an invalid image registry. Allowed registries are quay.io. So you can see our Gatekeeper policy acted as a last resort safety net that has prevented the deployment of an image from an untrusted registry. Okay, great. But the developer had to wait for the entire pipeline to nearly complete in order to eventually see it fail. That's rather time-consuming and expensive. Wouldn't it be great if we can shift left so that we can add these safety checks earlier in the pipeline so the developer can receive more immediate feedback? Well, that's precisely what we'll do next. Here we're deploying a different pipeline that adds a step earlier in the pipeline to deploy the application using a server dry run. That way we can effectively determine if Gatekeeper will succeed or fail this pipeline run as soon as possible. Now let's rerun the last pipeline run. We'll just Alt-Tab to switch over to our Tekton dashboard, and we can see the list of pipeline runs here. The previous one has failed. So here we can quickly restart the last pipeline run. Now let's switch back and observe how the pipeline run is doing using the Tekton CLI tool again. We can see that we first fetch the repository successfully, but now we attempt to apply the OPA policy immediately after using server dry run, and it's failed for the exact same reason, because the container OPA example app has an invalid image registry. Allowed registries are quay.io. Okay, cool. So we've managed to give the developer feedback earlier. All this was done using Gatekeeper, but there's another alternative using Conftest, and we'll try now. This particular pipeline introduces a step to evaluate our policy using the Conftest task hosted on the Tekton hub at hub.tekton.dev. We'll apply that pipeline. Now let's rerun the last pipeline run. Let's observe the pipeline run again. Keep in mind, we can still leave Gatekeeper to be a last resort safety net to verify policies before the pipeline completes and deploys anything. But Conftest can be used earlier in the pipeline as well instead of relying on server dry run. Conftest is also really valuable in evaluating policies for structured data that is not in the form of Kubernetes APIs, such as deployments, services, and CRDs. Here, you can see we have the same failure via Conftest. Okay, let's go back to the developer scenario. Let's say the developer gets approval to use the registry that previously violated the policy. As a cluster admin, we can use GitOps to make changes and/or make runtime changes to Gatekeeper to modify the policy. For example, here we modify the runtime policy being used by Gatekeeper to add the additional trusted registry. Then using GitOps, we'll also have to modify the policy that Conftest is using. This policy would typically be stored in a separate repo, but we're using the same repo as our test application for example purposes. We commit and push the change. Now let's watch the pipeline run one last time. Now that the pipeline has completed, we can scroll up and see that we fetched the repository, the Conftest step has now passed, we built the image and pushed it, and deployed the application. We then check that we actually successfully deployed the application. And we see here that our change has now taken effect. Thank you so much for joining us today. Here are links to learn more about Tekton, OPA, Gatekeeper, and Conftest, as well as a link to the demo tutorial you just saw. Enjoy the rest of CDCon.